All right, in this video, we are going to talk about mutually exclusive events. So, two or more events are mutually exclusive events if no two of them have outcomes in common. All right, so basically, no two of those events can occur at the same time. Okay, so let's take a look at this first example here to see what that says. In this example, we just have two events, and here we are going back to that experiment about drawing a card from a standard deck of cards and looking at the suit of the drawn card. So our sample space, right, was clubs, diamonds, hearts, and spades. And so R is the event that a red card is drawn, right, from the deck. And so, therefore, that event would be the event containing diamonds, right, because the diamond cards are red, and hearts, because those are also red cards. And then um, B is the event that the card drawn is a club, right? And so that would be the event that only containing clubs, all right? So here are our two events, okay? And so if I look at R and B and calculate R and B, which we've done before, right? Remember what R and B are. Those are the set of all outcomes that are in both event R and in event B as well. And so you can see here that there's nothing in common. There's nothing in here, and so the event R and B is the empty set. There are no outcomes that are common to these events, right? And so, and if that's the case, right, then we say that R and B are mutually exclusive. Okay? So if they have nothing in common. And another way of saying they have nothing in common is that the and, right, of the two events is the empty set. All right? So that's the first example. Uh, if you have more than two events, right, then you have to look at each pair that you can make of those events. All right, so let's look at an example like that. So that would be example 4.68. All right, and let's take a look at what that says. So over here, I've got these. I already listed out these events, so we didn't have to like keep flipping back and forth and looking at those. And so let me make a little bit more room here. Okay. So first off, in part A on 468, they want to know are A, oops, and B, are they mutually exclusive? All right, so what I would do is calculate the event A and B. All right, so I am looking for all elements in my sample space that are common to both A and B. So this has a 2 and a 3. Neither of those are in B. B has a 6, 7, and 8. Neither of those are in um, A is either, right? So they have nothing in common, right? And so therefore their intersection is the empty set, right? And so what we would say is A and B are mutually exclusive. Right? This was from the horse racing example that we've been looking at. And is it possible that, let's see, A was the long shot, I believe, the long shot wins, and B was the event that a horse numbered 6, 7, or 8 wins? Is it possible that when you run this horse race that both of these events occur, right? That the horse that wins is a long shot, in other words, number 2 or 3, and also either numbered 6, 7, or 8? And the answer is no. That cannot happen at the same time. Okay. All right, next is part B, right? And part B, they want to know if events B and C are mutually exclusive. All right, so if we look at B and C, right, and see what they have in common, B is 6, 7, and 8. C is 1, 2, and 3. So again, right, we see that they have nothing in common. There's no element of the sample space that's in both event B and also in the event A, right? So we would say that B and C are mutually exclusive. All right, next up is A, B, and C, okay? So we want to know if A, B, and C are mutually exclusive, right? So what we would have to do is look at A and B. We would have to look at A and C. We would have to look at B and C and calculate all of those out. Well, we've already done A and B, and we know that that is empty, right? And then we know that B and C, that is also empty, right? So the only one that we really have to do extra here is A and C. So if you look at A and C and calculate that out, A is 2, 3, and C is 2, right? So the A and C is the event containing horse number 2. And so because this one is not the empty set, then, right, we would say that A, B, and C are not mutually exclusive. It is possible for A and C to happen at the same time, right? You know, one of the long shots wins, and let's see, I don't think I have that right. Long shots. Let's see, what was A again? The favorites. Yeah, that's not quite right, is it? The favorites were 3 and 4, so that should be A. It doesn't matter. This is. I guess we could go ahead and fix that. So A, sorry, I wrote that down wrong. Just to kind of go with this here in case anybody's looking back at it. A really should be the event that one of the top 2 favorites wins. That's the ones with the lowest odds. So A really should be 3 and 4. So let me fix that. I don't think it's going to change a lot in here. So yeah, I didn't really notice it till that one. So A is actually 3 and 4. Okay, so that's not going to affect A and B. They're still mutually exclusive. A and B still have nothing in common. And part B, B and C, they don't have anything in common. All right, and then the only effect that it had was that A and C, what they have in common is not 2 but 3. Okay, so it didn't really affect anything. All right, so since A and C can happen at the same time, and that was that a long shot wins, right, or one of the favorites wins, and also at the same time the horse's number is at most 3, so 1, 2, or 3. That can happen at the same time, right, if number 3 wins. All right, and so because this isn't empty, we would say that A, B, and C are not mutually exclusive. All right, next up is D. So that's A, B, and D. So in this one, we would have to look at A and B. We would have to look at A and D. We would have to look at B and D. All right, so A and B, A and D, and B and D. All right, we want to know, are A, B, and D mutually exclusive? All right, so A and B we've already calculated. That's the empty set, right? A and D, don't believe we've done yet, right? So A is 3, 4, D is 2, 5. So if you ask, hey, what's common? What elements are common to both A and D? Well, there aren't any. So therefore, the intersection, right? Or sorry, I keep saying intersection. The and A and D event is the empty set. All right, and then B and D. B is 6, 7, and 8. D is 2 and 5. So you can see that events B and a D also have nothing in common. So it's empty set here. So with A, B, and D, right, they are mutually exclusive. A, B, and D are mutually exclusive. No pair of those can happen at the same time, right? Or other combination of them, okay? All right, and let's see. Part E is A, B, C, and D, right? So we'd have to check A and B, right? Our sets are A, B, C, and D. We want to know, are those mutually exclusive, right? So technically, right, we would have to check A and B, A and C, A and D, right? Then B and C, B and D, and C and D, right? We would have to check all those, but there's really no point in doing that, right? Because we already know, right, that A and C can happen at the same time, right? Let's see, where's A and C? Over here. All right, we already know that A and C, the and of that is the event containing 3, and that's it. Once you have one of these that has a non-empty and, right, then the problem's over, right? And you can say that they are not mutually exclusive. A, B, C, and D are not mutually exclusive. Because, right, there are some of these events that can happen at the same time. A and C can happen at the same time. So that's really, if you find one that's not empty, right, then the problem's over. But we can, just to show you that there's some others, we know A and B is empty. We know A and D, right, that is the empty set. And B and C, that's the empty set. And B and D is the empty set. And then C and D, they have a 2 in common, right? So, you know, if the question is, are they mutually exclusive or not mutually exclusive, right? If you suspect that they aren't mutually exclusive, then you can stop right here. You don't have to calculate the other ones, okay? All right, so I think that is it for mutually exclusive. It is. Okay, so that is it for this video.